Hi my friends, today we'll model this part, superior bearing, which has some interesting features, as you can see by taking a look at the part itself. As you see, there are two cylindrical ends, a rib, and I ask you to model this rib in your usual ways by using the drawing, and then to look at my tutorial. Another thing is this feature from inside, which has a special form, as you can see. Let's take a look at the drawing. This is the drawing. You see, sectioning this part AA with the line AA, we see what is inside, and you can notice that this is a symmetrical construction. The difference is between the two cylindrical part length. This is 50 from the center and this is 68. Another interesting thing is this end of the object. Well, having all we need, we can start the modeling. We start by creating a sketch and the plane XY. We draw two lines which are center lines. At an angle of 127, as you can see. What I want to do is to create this cylindrical end only outside, and this one. The angle is 127 and dimensions are 86 outside with a length of 68. And you have to notice that these two ends outside of the interior, these ends are at a distance of 54 from the end, which means this is 14 from here to here, and the other one is also at 14. This is why I say that the mid is symmetrical about this axis, and the interior is an offset of the exterior. This is radius 13 and this is radius 6. So we can consider this center for both interior and exterior radius or radii. So we draw from this end a line and an arc if I select this without clicking, I have perpendicular, and here also perpendicular, and then an arc. Then line, up, down. This must be connected, as you see here. Okay. Now, dimensions. This is the first, which is 86. Home. This is also 86. The distance here is 68, and here is 50. The radius is 13 to both arcs. They are symmetrical. And now I draw a line between these 2 points because I want to make tangent each arc to this line, as you can see. The distance is 14 on this direction, and also 14 here, but we don't have a line. I cannot select 2 points and to place a dimension as along this, so I draw a line, a small line here, which I hope is perpendicular or parallel with this one. So I can place here a dimension between that line and this point of 14. Good. This is 64, as well as this 64. One dimension's missing, needed, which is this dimension. We can use this. This is the end of that small line, because we want always to have fully constrained. I make something. I create a constraint that this point to be on this line, and now it's fully constrained. Finish sketch, F6, Now I want to apply revolve on both. This is the first with this axis plus the other one with its axis. Okay. Now I create a plane, a work plane, mid plane between two planes. This plane. I select it to create a sketch, F7 to see inside, and I project geometry, as you can see. And now extrusion, starting not from the plane but from the face to the other face. Okay. We go further with a rib. You see, this is the rib. Maybe the part is more suggestive. This is, and dimensions are 57 and 30. Let's create this new volume. We cannot use the rib tool, so we work manually in this plane, F7, where we draw a rectangle in 3 points. 1, 2, 3 points. This line must contain the center point. We project some geometry. This, let me project this line perpendicular this line on the projected line. 57 is this dimension. Now we project this face and this face to make coincident points with them. Fully constrained. Finish sketch. Extrude. Symmetrical. 30. Okay. Now let me make here 2 chamfers of 3 to verify this tiny distance between the corner and the chamfer. This is important here. We continue with this feature, which has a section here. The thickness is 18 and the width is 50 plus 10 plus 10, because these arcs of radius 2 are tangent to the ends of this triangular shape. That contour is placed in a plane parallel with this face of the rib, which contains the center point. So we have to create a plane based on the face of the rib and containing that center point. Let's create that plane. plane, center point. Good. Now we draw the contour for extrusion outside the plane, starting with an arc and continuing with a line, because we know some things. Line, arc, a very small arc, a large one. I keep press the mouse button now, and this is not tangent. The other three already are. Now all the four. I draw a line, construction line between these two centers, and I apply, this is a special configuration of a reference system, so I select horizontal to place this vertical. This is the situation. Equal for these two arcs and also equal for the other two, because everything is symmetrical here. Now the distance, which I called thickness, which is 18, radius 2 at the ends, and the distance here of 50 plus 10 plus 10. Okay, the center of this shape is placed on the center point. Extrusion, the other direction of 1/16. Okay, the plane is no more useful now. Good. Next is the triangular shape. 40, 50, radius 10, and tangency at the ends. The thickness is 11. Sketch on this face. 1, 2, 3 equal circles. And these two lines. Good. This is vertical. This is tangent. And the distance here is 40. These two are equal, these two sides. Okay, trim, and radius of 1 is for all, 10. Very good. Now we extend this a little, and we move this point on this vertical. Then we place closer to be tangent, and this ends tangent between these two and between the other two. Okay, fully constrained. Finish sketch. Extrude this 11 the other direction, but join, not cut. Okay, now on this face I create a circle to make this boss with dimensions of radius 10, of course, 22, and here is spherical. I must write here spherical. Yes? Now is okay. Good. Then finish sketch, extrude the circle only, the other direction 22 with join. Okay. Then the spherical end, we create a sketch here, F7, with a circle the same diameter with this one, a line, a vertical line, trim here, coincident the line with this center, make it center line, and place over the circle here. Finish sketch, revolve this. Okay, this is the final spherical face. Now the holes. You see there are 3 holes, metric 10, centered on the round corners of the triangle, 25, 18. Sketch, exit sketch, hole, metric 10, yes, 25, 18 on this and this holes. Okay, another hole on the same face is this one, metric 8, pitch of 1, which is through the part, yes, in the center, this center of the triangle. You see it goes through the center point. So I make a new sketch, the point is the center point projected here, and then a new hole on this point, metric 8, with another pitch finer one, which is through, but the thread is only 6 millimeters depth. Okay, now there is a hole also here in the rib. Yes, good. Next is the cylindrical face here. You see, cylindrical with a radius of 135 millimeters. So we have to create an axis here at this distance from the face. We create a plane which is placed at minus 135. We make this visible, auto resize, and then the axis at the intersection of this plane with the plane XY. Good. We have the axis now. Here is the axis, and the plane XY we create a new sketch, a rectangle in 3 points. This one side is aligned with the axis, the other side is aligned with what I project now, this face. So its dimension on this direction are limited by the small lines I project now, and I use coincident to connect the margins. Okay, revolve. This is the area and this is the axis. And now you have to be very careful because we don't select join cut but intersect. Yes, everything is inside. This cylinder is maintained and the excess of this face is not maintained, so the face is round, as you can see. Now I create the core, the hollow core of this part, using dimensions: diameter of 64 for the center of radius 6 and the distance of 14 from the center point, and the same to the other part, radius of 64 and 14 from the center point. So these two are symmetrical about this axis. I'll create this volume as a new solid outside the part, and then I bring it inside and I subtract from the volume. This is the strategy. Let's apply it. Sketch in the plane XY, center line from left to right, constraints for it. One is coincidency with the center point, and the other is a dimension to the right left of 120, an arbitrary dimension, but we have to remember it. A new line is this one, which must be construction line and which has a certain angle, half of 127. Good. This must be a little longer to create here what I said. Line, up, arc, and back, perpendicular. Good. Dimension 64 is the diameter, as I said. Radius 6, and a distance of 14 to the end of the center line. Then mirror of almost everything here, but not the mirror line. Apply. Done. A new line, construction line, between these two ends of the arcs, and tangency of 1, which means tangency symmetrical to the other. Trim this end, and now we have fully constrained for this sketch. Revolve this contour about this axis, but as a new object, new solid. Yes, not any other option but this one. It is green, this object, and plus the other area, closed area about the other axis, not as a new solid, this. Yes. Okay, now we have two solids. One is this one and the other is this. Very interesting. Yes. We make what we did before. We create a plane, mid-plane between these two faces, and a sketch in this plane. F7, project geometry, finish sketch, extrude. This is a procedure we already made. You see the dotted line shows that we create a new feature in the new solid, the second one, to this face. Okay, visibility, and now I move bodies, specifically this one, with minus 120, that arbitrary distance I place here. Okay, now there are two solids, one inside the other. I apply combine by selecting this base body, cut, and the other body, which is this one. I can select them from here. Okay, XY is the plane where we create a sketch. F7, and we draw lines. Now it's fully constrained. Good. We don't finish the sketch. We apply R from revolve. We select an area and an axis, cut, plus the other area and the other axis. Good. In the drawing we see there is another hole, 12 with a pitch of 1.5. There are two chamfers internal of 0.5 and these holes. So let's place them. Then we have only fillets. Good. Hole, we turn the part with this face, we select the center and the designing thread 1.5 instead of 1.75. To this for the thread with full depth. Okay, this is the result. Then a chamfer here of 0.5 and also on the other side. Okay. Fillets. There is this dimension radius 6, this dimension radius 8, radius 6 is about the rib, radius 8 is here, and radius 2 is up both on the internal and external 2. Very good. So fillet, but let me select this, which is 8, and also here 8. Then 6 is this 6, and all around the rib. Plus again 8 for this contour, 8, good, and 2 here up. This is 2, and also this, and here. That's all. Okay. Some other not accepted. Okay. Let me see. I apply here. Okay. I apply here. Okay. You see, if you apply separate fillets, you have a better strategy. F6. My friends, the part is finished. Let's apply material, steel cast, but with the general aspect of steel cast, as you can see, and some faces to be machined. These two, the 0.5 also, and on the other face the same. I keep pressed the shift button to make these selections. And also this face to be machined, still polished. F6. Yes. I think you would like to know, however, how I did to get this front page image from our part. We modeled it and it looks So, how can I make it such a nice presentation? Well, you have to apply the following procedure. Place the part in a position you think is very suited for your intentions. Select perspective as well. For instance, this or this can be your option, and then go to View, Visual Style, Realistic. You see how it looks now, but you can improve everything by using this solution, two lights, and to apply settings for two lights, these two lights. You have here the light 1 and the light 2, yes, and you can change their positions to obtain what you want. The color for the light 1 is white. Click here to select this cursor and use the arrow keys on your keyboard. I go down and you see something is changing here on the part. I go down more and more, and here is something more interesting. Click on the other cursor and use left right. Left right, I go to left, I go to right, and I select this position. I go to the light 2, I select the color yellow, why not? OK, and you see something changed. Click on the cursor and move the light wherever you want, for instance here, and the other one maybe here. I select white here, excuse me, to be like my model. Save and close. You have my tutorial number 155, where I presented you the SNI paste application. Go there and see how to capture this image to place it wherever you want. That's all for today, my friends. Bye bye.